Good morning, ladies and gentlemen. It's an honor and a privilege to be at the very first SANS SIM Summit, so I appreciate the invitation to be here. Justin asked me to speak earlier this year, and I looked at my calendar and I said, man, November, right after Thanksgiving, heading into December, I know this is going to be a crazy time of year. I know that we're working on our next generation of software, and we're trying to get it out the door as quickly as possible. But this is an important event, and I want to be here to support the community. I want to be here to support you, ladies and gentlemen, as we all work together to try to catch more bad guys, as that's what it's all about. And as I talked about, I started Security Onion in 2008, and really it was all about trying to, as Ismail said, trying to take all of the sysadmin work out of catching the bad guys, because we have this unjust and imbalanced equation of the adversaries having such an advantage over us, and if we're spending so many hours manually compiling software and troubleshooting this and debugging that, then that's less time that we have to catch bad guys. So let's talk about that exact thing, about tactical acceleration, about what we can do to get faster and faster every single day. Now, I'm not going to talk about any rocket science. I'm going to leave that to the speakers that follow me. They're going to be the really smart folks talking about the really smart things. But what I'm going to talk about is the fundamentals. Because as we go and work with customers, we see customers that have kind of forgotten about those fundamentals. Those things that are so important that if you don't have them right, they're going to slow you down, and they're going to prevent you from catching bad guys. So let's crawl before we walk. These are some of the fundamentals that we'll talk about. So we'll start with instrumentation. And, so I'm an old school gamer, and if you're an old school gamer like me, you remember the old Nintendo that had the square controller that hurt your hands, right? You know what I'm talking about. You had the B button to run, you had the A button to jump. And after playing Mario for a couple of days, I just got to the point where I was holding down the B button because I was running all the time. I was trying to go as fast as I possibly could. Now, my sister, to this day, when she plays Mario, she does not hold down the B button. She does not run. Mario's just kind of walking slowly. And it drives me nuts to watch her play Mario. And I think this is kind of symbolic of some of the security operations centers that are out there. They're not holding down the B button. They're not running. They're just kind of walking. And so I think Mario's a good symbol of this because, hey, Mario's a plumber. We need to talk about the plumbing that we have in place that's going to allow us to run through our networks and catch those bad guys. So let's talk about accelerating our plumbing or our instrumentation. Well, the first thing we need to do is we need to generate logs. All right, we've got network, the network perspective of, we've got network-based IDS alerts coming from Snort or Suricata, and that's great. But I think we all kind of realize that even though IDS alerts may start an investigation, very rarely do they ever complete an investigation. So that's why we have to surround those IDS alerts with all that contextual data. Connection logs, DNS logs, FTP logs, HTTP logs, so on and so forth. So we can get all of that contextual data from Suricata, from Bro, from other network appliances, and that helps us to tell the story of what the bad guy actually did. Now, me as an incident responder, I really want to have full packet capture. Now, that's not always feasible in every environment. I realize that. But ideally, I'd love to have that. But just like anything else in life, there's a delicate balancing act here because as you're building network sensors to collect all this data, you may overwhelm your sensor, you may start dropping packets. So that's something that we have to be aware of as we're building these things. Next up is infrastructure, because apart from our network sensors, we may have some existing firewalls, proxy servers, other network appliances that can generate logs that we need to be collecting. And that's going to assist us in running down these bad guys. Now, the thing to keep in mind here is that a lot of these network appliances, they speak syslog. We can consume syslog quite easily. However, some vendors' implementation of syslog may be suboptimal, right? So maybe it only speaks UDP, so maybe we're dropping packets, maybe we're losing logs. So that might be a blind spot in our enterprise visibility. So let's keep that in mind because that will slow us down as well. Now, from a network perspective, that's great. We can get our network infrastructure devices, but how about endpoints, right? We all want to have more and more endpoint visibility. Obviously, we want to have antivirus and or host-based IDS alerts. We want to be collecting those things. But just like we said before with network-based IDS alerts and the fact that we want to surround those network-based IDS alerts with contextual data to help us tell the story, same thing from a host perspective. We want to have full, comprehensive operating system logs. We want to have application logs, PowerShell. We want to look for persistence mechanisms, and we want to look for process auditing. So if you're not already using tools like Mark Rusinovich's AutoRuns or Sysmon, these are great free tools you can download from Microsoft today and provide you some great endpoint visibility for your environment. So let's talk about automation because, we talked before about how a lot of these things that we build, if we're spending more time building them than actually using them to catch bad guys, well, then our ratio is kind of out of whack. So if you're still rolling network sensors by hand, maybe it's time to look at some more of an automated solution so that you can spend more time catching bad guys. Now, what about endpoint agents, right? If you have to go and deploy those endpoint agents, that's going to cost you some time as well. So, for example, I had a customer that they had over 700 Windows servers in their enterprise. They wanted to deploy OSEC to those Windows servers. So we automated that because ain't nobody got time to be installing OSEC manually on 700 boxes, right? So automate the deployment, automate the upgrade cycle so that we have more time for the real work of catching bad guys. All right, so we're generating logs. That's great. That's step one. That's fundamental. We have to do that first. Now we need to collect those logs because if we don't have them in a place where they're readily accessible, then that does us no good. I worked an incident several years ago where we had network-based logs, and that was great. But we had a sysadmin team collecting their own syslogs, and we had to go and request logs from the sysadmins. Right? We all know how that goes. They're busy. They have their own agendas. They have their own priorities. And so if we don't already have ready instant access to those things, then that's going to slow us down. Right? So we need to start thinking about collecting these logs. And if we're sending these logs across the network, what do our network speeds look like? Right? Do we have a global enterprise network? Do we have some remote office on the other side of the world that has a slow WAN link? And if we're now sending all of our syslog across that slow WAN link, are we flooding that link and slowing it down? That may be problematic. Also, what happens if that network link goes down, right? Are those logs being buffered, or do we just lose them forever? So one of the things that we kind of do from an architecture standpoint is we typically try to keep data as close to its point of origin as possible. And so this might mean that instead of sending logs from a remote office all the way across the world to my data center, maybe I deploy a box out there at the remote office, keep the logs there, but still have them in a manner that I can query them remotely very quickly and easily whenever I need to. Yes?
So what about, how does encryption factor into all this? Because I worried for a long time about all this syslog traffic that's generally not encrypted unless you encrypt it, and a lot of people forget to do that. So doesn't that impact things like this? Because you have to encrypt it.
Absolutely. The question is about encryption. Traditional syslog is clear text. It's unencrypted. That is a security issue in and of itself. So we absolutely have to be cognizant of that. What we typically do is all of our transmission that we do specifically in Security Onion is encrypted. We use SSH tunnels to encrypt any standard traditional syslog.
So use tunnels rather than encrypt the traffic?
That's what we do in Security Onion itself. Yes, correct. All right, so that speed of that network collection, those log collections, that's something that we have to be cognizant of. There's also a cost, right? Because traditional syslog, everybody's familiar with that. It's a standard, easy to read, single line log format. but a lot of folks are moving to JSON. JSON is great, right, because key value pairs, it's easier to parse if you're talking about sending that into something like Logstash. Logstash doesn't have to work as hard because the JSON format is already telling it this is this field, this is that field. However, right, this is the discussion that we've had in our community, which kind of fits into what we were just talking about. If you're sending this stuff across the network, across a slow WAN link, those JSON logs are going to be at least twice as big as the original syslog, right? So if you've already got a crowded network link, you may have made it a little bit more crowded by using JSON. So there's always a trade-off. We have to be cognizant of that. We have to be thinking about those bandwidth costs. Another cost, commercial SIMs. I'm not knocking commercial SIMs, but we're all aware that if they're priced based on log volume and your manager tells you that you've got a budget and you've got to stay within that budget, then you are then in the position that you have to pick and choose which data types you're going to send to this commercial SIM. And that's going to limit our visibility. That's going to limit our incident response capability. And so maybe we need to consider augmenting our SIM with maybe an open source solution that would not be limited based on log volume. And that's really going to, again, accelerate us in trying to chase down these bad guys. So now we're generating logs, we're collecting logs. Now it's time to ingest those logs. We're going to store them in a database so that we can search. An example would be Logstash, then writing those logs into an Elasticsearch backend. But something that folks tend to forget about is looking at that pipeline and looking for errors, looking for logs that we did not get. Because a lot of times folks will say, well, I'm getting logs. It must be working, right? But maybe you're only getting 10% of the logs that you should be getting, right? So this is something that on a daily or some other regular basis, we need to be looking for, are we getting the logs that we expect to get? Are we getting any errors? Are we getting any delays or anything like that? If you're into the Elasticsearch, Logstash 6.0 now supports multiple pipelines. That's a really great feature that's going to help folks really accelerate that ingestion process and make their ingestion pipeline a lot simpler. Now, I do have to go on a sidebar rant here and talk a little bit about timestamps. I think we all kind of know and appreciate. Thank you, thank you, thank you. I think we all kind of know and appreciate the fact that timestamps should be stored in UTC. We all kind of realize that academically, intellectually, that's the way to go. However, for reasons, folks are still storing logs with timestamps in local time. Sometimes you hear, well, we're a very small organization. We're all in the same time zone, so why do we care about UTC? Well, obviously, you have the time warp issue where twice a year you're going to go, the daylight savings time is going to adjust the time, and that's going to be problematic from an investigation standpoint. But now also think about this. Even if your organization itself is in a single time zone, what happens when you have to work with an outside third-party provider, maybe a consultant like Nick, and you have to then try to correlate those logs with other logs from other organizations, right? UTC is the way to go. I dealt with this an incident years and years ago where we had our network appliance logs that were UTC the way that God intended, but in going to the sysadmins and collecting their syslog and trying to compare those. Of course, those were in local time. And of course, they weren't synced to the same NTP server. So even if you did the daylight savings time offset, they were still off by 3 to 5 minutes. It makes correlation a nightmare. Mick is nodding his head because he has lived this nightmare. It's absolutely ridiculous. And that's going to slow you down. Now, next is augmentation. Now, this is the first picture that we see that's not just a human. Right? This is a human on a bicycle. And this is important because Steve Jobs used to talk about how computers are like a bicycle for your mind. Right? And the reason why he said that is because he told the story of an old article in Scientific American where they did this study and they measured the efficiency of locomotion for different species of animals. And what they decided was that the California condor was the most efficient animal. It could go the farthest and the fastest based on the amount of energy expended compared to all the other animals on the planet, including human beings. We were pretty inefficient compared to the California condor. But Scientific American had the insight to measure not just a human on foot, but also a human on a bicycle. And when you do that calculation, you measure a human on a bicycle, we blow the entire animal kingdom out of the water. Why? Because humans are tool builders. We build tools to assist us, to accelerate ourselves, to augment our existing capabilities. And so that's what we need to think about doing here. And specifically, as we're bringing logs in, maybe we take our IP addresses and we do kind of the traditional, do reverse DNS lookups, do GeoIP lookups, maybe do thread intel matching, the kind of stuff that you may do by hand. Well, maybe we just go ahead and do it automatically so that an analyst doesn't have to manually do it. Same thing with host names, thread intel matching. Justin Henderson deserves a huge amount of credit for these next 2 bullet points, because he said, traditionally what we've told people is, if you're looking for domain generation algorithms, you're looking for malware that's generating these long, random-looking domain names. Well, you take your list of DNS and you kind of manually inspect it, right? And you look for those random-looking, and that works somewhat, although it doesn't scale that well for large enterprises. So Justin said, well, why can't we automate this? Why can't we build a tool to let the computers do this hard work for us? And so he worked with another good friend of mine, Mark Baggett. Mark Baggett wrote some Python. Freak Server was born so that we can now automatically take host names, take DNS lookups, and measure the entropy and see if they look random compared to standard English dictionaries or your standard DNS lookups. And then likewise, Justin also said, a lot of times adversaries will register brand new domain names as they're building their new infrastructure. And so maybe a strategy might be, hey, let's look for newly registered domain names, okay? And instead of analysts manually taking a DNS name, doing a whois lookup, and looking for that registration date, maybe we just do that automatically on the front end as that log is being ingested. So again, he spoke with Mark. Mark wrote some Python, and thus Domain Stats was born. So this is a great way to, again, augment your existing capabilities while accelerating your analysis. Now, we talked before about IDS alerts, right? And whenever I look at an IDS alert, I'm interested in the IDS alert, but I'm interested in the rule that generated that alert. Why? Because we all know that IDS alerts are prone to false positives. We want to make sure that this is going to be a true positive. We also know that because they are prone to false positives, rules change constantly. They're constantly updated. They're constantly improved. So include the rule itself in the log, right? If you have to do a lookup to include that rule, do the lookup, and also include a hyperlink that the analyst can then click on in real time to go and view the current version of the rule, right? Because that way you can compare the two, you can see if the rule has changed, see if maybe you're dealing with a false positive that has already been resolved. All right, so now we've kind of gone from the human on a bicycle to now we're talking about a jet-powered truck. Okay, so pre-investigation automation. Before a human gets involved, let's do some more automation to help automate away those things that take us so long. So take a step back, think about your daily workflow, think about those things that you do 10 times a day, maybe 100 times a day, and even if it only takes you 3 seconds, 5 seconds, if you can automate that process and you multiply it by that 10 times or 100 times a day, that adds up very quickly. And I'll tell you a story to illustrate that, another Steve Jobs story. So this goes back to the beginning of the Macintosh, right? The engineers had developed this Macintosh. Steve Jobs looks at it, he turns it on, and he waits for it to boot. He tells the engineers, this takes too long to start up. We can't wait this long. You have to make this shorter. So the engineers say, Steve, what's the problem? You turn it on, you walk away, you get some coffee, you come back, your machine's booted up, and then it's running for the rest of the day. What's the big deal? Steve said, you don't understand. This machine is going to be used by millions of people. And if you can save them 5 seconds apiece, multiplied by millions of people, you can save lives. Right? Now that's a kind of a silly example, but it's actually even more important for us because in the work that we do as network defenders, and especially if you're affiliated with a military organization, you may actually be able to save lives if you can accelerate your processes. So think about those things that you can do, those little tiny time wasters, that if you can automate that, you'll be much better off in the end and you'll be able to catch more bad guys. So now we move into the actual investigation phase. We think about accelerating that. So just a couple of very quick strategies, again, not rocket science, but take your big data that's sitting in your SIM or whatever system you have and identify outliers with group by. You may have heard this being called stacking, right? So as an example, take all the DNS lookups on your network and group it by fully qualified domain name and then sort it by count. All right, so now if you have a machine that's compromised, and maybe it's doing some beaconing, so maybe there's a DNS lookup every time there's a beacon. So if you have a DNS lookup every single minute for the same exact host name, then that's going to bubble up to the top of those results. Now, even if it's not doing DNS resolution, right, you, instead of using DNS logs, you take a look at your connection logs. Right? And if it's beaconing out to the same IP address every single minute, again, that same process of stacking your connections is going to make that beacon bubble up to the top. Now, very similarly, we can do long tail analysis, right? Because if you do that same process of stacking your data, and if you were to graph it in like a bar chart, you would have that first initial spike. You would have a smaller spike, and if you look at the graph, it would be curved out to this long tail, right? So you want to look at the very end of that long tail, and that way you look at the spike initially, that's one outlier. You look at the long tail, that's another outlier. So for example, show me a list of all the processes executed on every single Windows box in my enterprise, group it by process name, and now let's look at the long tail. We look at that, show me that one process that only executed on one box in my entire enterprise. Right? That's an outlier. That's interesting. Streamline your workflow. Right? So, again, not rocket science. Hopefully you're already doing this, but think about those queries that you run periodically that may be kind of an ad hoc kind of a thing, but if you can go ahead and pre-build those and save them, then that's going to speed your mission. We need to reduce friction. So think about those things that as you're pivoting from one data type to another, or perhaps pivoting from one interface to another, that's slowing you down, right? It's pretty simple to think, well, you know, I'm in this interface, I'm looking at an IP address, and I want to do research on the IP address, so I'll just copy the IP address, I'll create a new browser tab, I'll go out to Google, and I'll search for the IP address. That only takes 2-3 seconds, right? No big deal. But on the other hand, if you can generate a hyperlink that does that automatically, and you just click on that, you saved yourself a couple of seconds, and you automate that, you multiply that many, many times, that saves up a lot of time. Yes, sir?
So, do you have any quick suggestions on the top of your head? How do you overcome, I don't know what the word is, but people are used to doing things their way.
What? I think that's a great question, and it relates to how do you overcome organizational inertia to having always done the same things the same way, right? And I think it goes back to kind of the insanity test, right? If you keep doing the same thing and expect a different result, right? So maybe at the end of the day, maybe we have to do a bake-off. Maybe we have to collect some metrics around how long does it take analyst X to do this investigation versus how long does it take analyst Y to do this investigation, and realize that there's a delta there, and if we can demonstrate that delta, if we can record that delta, and if we can squash that delta across our organization, that's going to make our entire organization much more efficient. All right, so thinking about, especially things like IDS alerts, we all kind of are familiar with the proverbial, million IDS alerts, or you hear these reports in the press about, oh, our organization sustains 1 billion attacks per day, right? Clearly, that's not sustainable. Now, what we need to be doing, if we're not already, is maybe defining a queue of alerts which we must deal with on a daily basis. And then maybe once we've defined that queue, maybe look at it and look at the number and figure out, is this actually sustainable for our organization at our current staffing levels? Do we have enough FTEs to actually handle this workload? Maybe we need to tune our rules. Maybe we need to tune our thresholds. Maybe we need to, again, it's a delicate balancing act because maybe we don't want to turn all of our IDS alerts off. Maybe we want to keep them for investigation, but maybe define more of a primary queue of more important alerts that we absolutely look at on a daily basis. Search all the databases, right? Again, this kind of goes back to something we touched on before, and that's that, in modern enterprises, you have lots and lots of different data stores. You may have your own security team databases. Your sysadmins may have their own databases. Your network engineers may have their own syslog collectors. And hey, wouldn't it be nice if we could search across all those at the same time? Well, for example, Elasticsearch version 6.0 includes cross-cluster search. So if you have your own Elasticsearch instance, sysadmins have their own, network engineers have their own, you can search them all at the same time. Simply using cross-cluster search makes you much more effective and efficient. Next up, avoid slow rodents, right? We all love pointy, clicky GUIs. We all love how easy to use they are. However, there are those times when clicking a GUI can slow you down. As a matter of fact, if you go back to the early days of my career, I was a sysadmin running Windows NT 4.0 server. I stumbled upon this website one day, and it was called Real Men Don't Click, right? And it was a great website because it was a bunch of old Unix graybeards who had gotten used to their warm, fuzzy command line interfaces, and now all of a sudden their bosses were telling them to run Windows, right? Run GUIs. And their mission in life then was to try to figure out how they could do all this command line stuff in the Windows world. So they wrote all of these scripts and all of these programs to allow them to do that. And I think that's something that we need to be thinking about. Again, is, GUI interfaces are awesome, but how can we avoid that slow mouse movement, keep our hands on the keyboard? And a great example is Kibana 6.0. It's got improved keyboard navigation, and so that's going to help you move much faster. So now we've done our investigation. We're kind of in the post-investigation phase. Let's see if we can automate a little bit there. Again, command line for the win. So maybe whether you're doing incident response or maybe you've identified a gap in your enterprise and you want to be rolling out some new tooling, some new instrumentation, command line for the win. We want to automate as much as possible. It's going to leave you with more mental energy to do more advanced tasks. And if you think about kind of the standard incident response model that we all know and love of Pickerel, and the last phase of that being lessons learned, that lessons learned phase is so vitally important that we communicate to our team members and outside of our team members. That communication of sharing ideas is going to make your team better. And if you can share outside your organization, you may get some valuable intel in response to that. So for example, I worked an incident several years ago. A bad guy broke into our web servers. We figured out who this guy was. We did some open source intelligence research on him and figured out that he had targeted a local university. We reached out to them. We had some friends there. And we said, hey, do you know this guy? And they said, yeah, he showed up on our doorstep with a vulnerability scan and said that we should hire him as a security consultant. Pro tip, that's not a viable business model, right? But this gave us some valuable intel because now we know this guy's motive. We know what he's after. We know what he's trying to do. And so the more that we can communicate and share information, the faster it's going to make all of us as a community. Meta acceleration. So how do we accelerate the acceleration? This is one of those things where we have to kind of take a step back. We have to give an honest appraisal of how do we spend our days. If you've got 8 hours in your standard shift, how are you actually spending those hours? Are you spending a good portion of it in meetings? And if so, why? When Richard Baitlick hired me at Mandiant several years ago, one of the first things that he told me was, Doug, I don't want you spending all day in meetings. I want you to avoid meetings as much as possible because I want you monitoring and defending the network, right? And that's so vitally important. And I think we all understand that in this room. Maybe our management does not, but that's something where we need to have a heart-to-heart conversation with them and say, look, meetings are awesome. I love spending time with you, boss, but the more time that we're in meetings, the less time we're actually catching bad guys. Then also think about the time that you are sitting at your desk doing real work. Well, how much of that is split between the different data types that you have, the different interfaces that you have, and what is the efficacy of each? And I think this gets to Craig's question earlier, and we need to be having an honest appraisal about how our workflow actually functions. Does it function? And how effectively and efficiently does it function? Are we spending too much of our time just focusing on IDS alerts? When I was a full-time incident responder, I made sure that I didn't spend more than 50% of my time focused on IDS alerts because I wanted at least the other 50% of my time dedicated to proactive hunting because it's that important. All right, so maybe you look at your day, maybe you break it out by percentage. This is not a recommendation, this is just an example. So maybe you review some IDS alerts, you do some proactive hunting. Leave some time in your day to focus on automation. All those things that we've talked about, leave a little bit of time so that you can actually do a little bit of automation every day. That kind of generates a snowball effect where every single day you're automating more and more and more, and you're getting faster and faster and faster. Now, as you're kind of building your daily schedule and you're doing this every single day, for example, every single day I get up in the morning and I have a certain number of things that I do every single day. I check a few websites, I do some IDS alert analysis, I do some hunting, and I do these things every single day. And if you make that a habit, if you do it every single day, you're going to build muscle memory, and you're going to get faster and faster every single day. And that's what we need to be doing. Accelerate your wheels, don't spin your wheels. If you've read Stephen Covey, you've heard the phrase, don't mistake the urgent for the important. We're all quite familiar with the fire alerts, the fire drills that we get every single day. There's always a new fire. There's always a new emergency to deal with. But as much as it's important for us to deal with the fires and those emergent things that are happening, it's also very important not to lose sight of what's most important. And even though we're talking about kind of tactical acceleration, that sort of day-to-day stuff, I'm presenting this here to say, let's not lose sight of the fact that we do have sort of longer strategic goals, and we do need to make time for that. And sometimes when we're kind of caught up in the fire du jour, and we're stuck down in the trenches constantly, you can't see past that trench. So sometimes we just need to get up, take a walk, and clear our minds. Accelerate your wheels, avoid the Ludic loop. I love this phrase, the Ludic loop. And I was reminded of this last night as I drove to the hotel. I passed by a casino. And inside of that casino were folks sitting there plunking quarters into the machines. And every time they would plunk in a quarter, they would get a little bit of a hit of a chemical in their brain that caused them to continue to plunk quarters into this thing, right? That's the Ludic loop. And I think we fall victim to this sometimes, especially when it comes to things like social media. Don't get me wrong, I love social media. I especially love Twitter. And Malware Jake is one of the best Twitter heads in the universe. So I love Twitter, but sometimes there are those circumstances where Twitter can be somewhat of a Ludic loop, where we get that hit. Or maybe it's Facebook, where you log into Facebook and you say, well, I'll just catch up with my friends. An hour later, right, you're still logged into Facebook, you're still looking at pictures of the hunting trip or the basketball game or whatever the case may be. So sometimes that Ludic loop can really distract us from what's important and will slow us down. Accelerate your wheels, don't reinvent the wheel. All right, so there's a lot of smart people in this room, right? We're all very intelligent. It comes with the territory of what we do. And sometimes we think that, we've got this idea, and so maybe we're the first person to have that idea. But turns out, many times, somebody has already thought of that idea. So take a look out at the internet. It's a great resource. Make sure that, yes, Make sure that you're not reinventing the wheel. There's a great thing that's out there called Sigma, a generic signature format for SIM systems. And this is such a great project, and I'm so very excited about it because it really allows you to avoid reinventing the wheel, right? Because commercial SIM vendors, again, not knocking the vendors, but if they have their own detection formats and their own detection strategies that are locked into that walled garden, well, that slows the rest of the world down. But if we can come up with sort of a universal format that can then be translated into all of those individual vendor formats, then that's going to raise us all up as a community. So look at that project, see if you can implement it in your environment. There may be some great detection there for you. And if you come up with a new detection strategy, contribute a pull request to their GitHub repository, right? So that way, not only are you benefiting from it, your organization is benefiting from it, but our worldwide community of defenders is benefiting as well. Any Fast and the Furious fans in the audience? There you go. Sometimes you just got to hit that nitrous button, right? And really the way that we do that is we need to be learning something new every day. And this is kind of my personal goal. Every single morning I get up and I say, what am I going to learn new today? Because I'm really not that smart. And your brain is a muscle and it has to be exercised. If it's not exercised, it's going to atrophy, just like anything else. So learn scripting, learn protocols, forensics, reverse engineering, or maybe even something totally outside of the lane of information security, right? Whatever you can do to grow and stretch your brain, to build new pathways inside your brain, it's going to make you smarter, it's going to make you better, it's going to make you faster, and help you catch more bad guys. The obligatory machine learning reference. There it is. So we all know about machine learning. It's very much debated in the community. But, however, I think we all kind of appreciate the fact that we are losing this battle, right? The attackers have such an advantage over us. We need to take every advantage that we can to try to rebalance the equation. And there's such a deficit of really skilled defenders out there, right? At some point, we are going to have to implement machine learning. Now, it doesn't work for every single use case in the world, but take advantage of it where it makes sense. Now, I'm a huge Star Wars fan, and of course, this is Return of the Jedi, and the speeders flying through the forest and dodging through trees. And, so I think this is really kind of symbolic of, sometimes in the course of this talk, we kind of talked about all these little things you can go to go faster and faster and faster and faster, and that's great, but as we kind of wrap up this discussion, I want to present a more nuanced view of, if you're always focused on going fast at the sake of everything else, right, what can happen? Well, if you're just going and focusing on going fast, you may miss something. Right? You may miss the forest for the trees. You may miss that adversary that's staring you in the face. You may make a wrong turn in your investigation. You may go down a rabbit hole, which causes you to do rework and ultimately slows you down. I'm a big fan of the phrase, slow is smooth, smooth is fast. Right? So to kind of sum up the whole talk, I want you to go fast. I want you to improve your speed and efficiency, but do it slowly enough so that it's smooth, right? And ultimately, by being smooth and not making mistakes, we can go faster, we can catch more bad guys. The Mandiant M-Trends 2017 report shows that the average dwell time for attackers in organizations is 99 days. It's gotten better than it used to, but it's still higher than we'd like it to be, right? So we have to find ways of getting faster, but we want to make sure that we're not doing that to the detriment and really slowing ourselves down. So finally, what can you do today to make yourself faster tomorrow? What can you do today to make your organization faster tomorrow? And finally, and most importantly, we're all here as a community. I said at the very beginning of my talk that as difficult as it was for me to be here, I wanted to be here to support the community because community is what it's all about. So what can you do today to make our community faster tomorrow? Thank you all very much.